Hi guys, Mr. Wertz here, back with another Algebra 2 video. This time, we're taking on function notation. So in this video guys, I'm going over the proper notation for a function and how to evaluate it. The majority of content in Algebra 2 is function focused, so this is why we're building it right now. And you'll know you're successful when you can evaluate an expression or a function like f of x equals 2x for an expression like x minus 5. So let's get started. Before we start function notation, we need to know what a function is. A function is a special relationship where every input has a single output. It's often written as f of x, where x is the input value. So what I am essentially saying is that whenever I choose an input, one input, it will only ever produce a single output. So when I choose an x, it only gives me one possible y. Some equations don't do this, so they're not functions. But if I take a look at the example, f of x equals x divided by 2, I know this is a function because every input x will have exactly one output, x divided by 2. So some samples, f of 2 equals 1, where that's an input of 2 and an output of 1. That would be another way to write this would be the coordinate pair 2 comma 1, and you guys have seen that before. The way to write the next one would be negative 10 comma negative 5. So that's another coordinate. And then the next one would also be 16 comma 8. So that's another coordinate pair. So remember, coordinate pairs are made of input outputs. So all I did here was recognize that these things here, inputs 16, output 8, can make a coordinate pair for this specific function. Now, you're probably asking yourself, how do I test that? We'll get to that in just a second, but I do want to specifically say that function notation is the way that we write a function. It's the precise way of saying that an equation qualifies as a function. The f of x notation, okay, so I am saying it f of x. You can see in my little piece of wonderful artwork here. Is another way of representing the y value in a function. So instead of saying y equals x for an equation, we have f of x equals x. They mean the same thing. So in this equation that I have in this box here, I could also have written it as y equals 3x plus 1. Well, now instead of y, I can use f of x. And that tells me, okay, that x is going to be my input variable, and the output range is going to be the operations that are happening to that variable. So in this case, in this specific equation, we are multiplying the input by 3, and then we're adding 1 to it to get our output. So you can use other letters, okay, to put for your functions. You can use G, H, J, K. I mean, honestly, you can use any letter, and you can use any letter as your input. Just realize that the most common is f of x, g of x, h of x, things like that. But you can use other letters. So how do you tell whether or not you have an equation that represents a function? You use the vertical line test. When you graph that equation, no matter where you draw an imaginary vertical line, those lines will only ever hit the graph once. So on the left-hand side, you have the equation y is equal to x to the second power. So I drew one imaginary line, a vertical imaginary line, and it touches the graph one time. And then I drew another one somewhere else, and it only ever touches the graph one time again. And I can draw as many of these as I want. I can draw an infinite amount of these vertical lines, and no matter where I draw them, it is only ever going to hit that graph y equals x to the second a single time. That means it is a function. For the other one on the right, multiple hits on this graph on the first line that I drew. I can draw, okay, I can in fact draw a imaginary vertical line that touches the graph just here at the origin. However, even though it passes the test at that one point, it has to pass the test for every point. So it doesn't pass it because it hits it here. So you can see that it hits it here and it hits it here. Because it hits it twice on the same line, or excuse me, on the same vertical line, that causes it to not be a function. So on the left-hand one, y equals x to the second, I can now write that in function notation to tell tell myself and tell any other reader that this is a function. And I would write that as f of x equals x to the second power, where that is saying that the input is x and the output will be whatever x to the second power is. So, to evaluate a function, what we're going to do is we are going to substitute the input for the function's variable. So if you're given an input, all right, you're going to put it into the function, and that means you are going to substitute it in place and replace all of the x's with either the given number, or later on I'm going to show you how to do an expression as well. So when you substitute it in a specific input, you're going to get a specific output. And remember, input is domain and output is range. So think back to the second section where we did domain and range. All of that is based off of functions. So let's take a look at some examples of that. If I have a linear function here, f of x equals 3x minus 5, find f of 4. Okay? So x is still going to be the x-axis, and f of x is also the same as the y-axis here. I graphed this equation. I graphed the linear equation f of x equals 3x minus 5. Now what I'm going to do is they're telling me to find f of 4. Finding f of 4 means that I need to substitute 4 in place of all the x's. I want to know the output when the input is 4. So I'm going to say f, and I'm going to replace it 4, f of 4 equals 3 times 4 minus 5. And again, I'm going to use my highlighter here. This is because I'm given f of 4. So it shows up here, and then the 4 gets substituted here. Remember, when you substitute, you need to use parentheses for your substitution. I'm trying to get everybody to switch into that. It says 3. I have 3 parentheses 4 minus 5 instead of 3 times x minus 5. You need to make sure that you use those parentheses. The parentheses are key to preserving negatives, and they're key to preserving the correct order of operations. So I'm going to tell you again, you need to use parentheses when you substitute. Don't be lazy. Don't forget this step. Most simplification errors happen because students don't use parentheses. So if I switch back, okay, to my pen here, I'm going to go ahead and perform the correct order of operations. And so f of 4. On the left side of the function, guys, there is nothing to do here, okay? F of 4. It doesn't become 4f. It's not f times 4. It's f of 4. And there's nothing to do. It is not simplifiable. It means the function value of 4. It doesn't mean f times 4. It doesn't mean 4 times f. It means f of 4. So leave it alone. Don't touch it. It is there to stay. On the right side, though, I can multiply 3 by 4, and then I can take 5 from it. So 3 times 4 here is 12. Take away 5. So the actual function value with an input of 4, and that's what f of 4 means, is 12 minus 5, or 7. So if I go onto my graph here and go over to where 4 is and go up, I see that it strikes right here at 4, 7. And that is exactly what should happen. 4, the input was 4, and the output was 7. So we created this input-output coordinate pair here, which is represented on the graph over here. I'm fixing my arrow. So it's represented on the graph over here. So now I'm going to do a quadratic function example. Find the value of h of x equals 3x squared minus 2x plus 1 when x is given to be negative 2. So essentially what they're saying in other words would be h of negative 2 equals, they want to know what this is. So what I am going to do is I'm going to use my highlighter here to illustrate to you guys again what you're supposed to do. You're going to take the negative 2 and you're going to substitute it here. You're going to substitute it here. And you're going to put the negative 2 in for here as well. So switching back to my pen, I get h of negative 2 equals 3. And this is where the parentheses becomes extremely important. Negative 2 squared minus 2 times negative 2. Again, the parentheses are very important, plus 1. Okay? I'm probably going to say parentheses are important until I run out of breath, but I'm going to continue to tell you guys because it cannot be ignored. Order of operations now for simplifying. Negative 2 to the second power is 4. It's not negative 4, guys. You need to write it in, type it in your calculator exactly as you see it here. It is 3 parentheses, negative 2 parentheses end to the second power. And then that tells your calculator to do negative 2 to the second power first, which is 4, and multiply it by 3. I'm simplifying one thing at a time. So this step, I only simplified the exponents. Okay? The next thing I'm going to simplify is multiplication. And that's going to be in this line here. So h of negative 2 is equal to 3 times 4 is 12 minus, and then 2 times, I'm not doing negative 2 times negative 2. I'm doing 2 times negative 2 here, and I get negative 4. And then plus 1. So you can see that the minus sign transferred down. 2 times negative 2 is negative 4. The 1 transfers down. So the final value here, I'm going to do all addition and subtraction in this step, and I go specifically left to right. I don't skip over stuff and do negative 4 plus 1 first. Nope, don't skip over anything. So 12, take away negative 4. We know that taking away a negative value is adding, so it's going to be 12, not h. It's going to be 12 plus 4 is 16. And then you're going to have 16 plus 1, which means that the final answer is 17. So if I look on the graph, I have just demonstrated that at 2, the graph should be 17 high. Negative 2, the graph should be 17 high. So if I find negative 2, which is here, and I go all the way up, I can see that it touches right here, and that point is in fact negative 2 comma 17. So that means that we have done this correctly. So now I'm going to talk about evaluating a function using an expression. Remember, when we evaluate something, we are replacing, we are substituting. So we're going to replace a variable in the function with an entire expression surrounded by parentheses. Then you need to perform any distribution and combining of like terms to simplify the function as much as possible. So take a look at this example, this quick example. If f of x equals 2x, and they tell me, and they say find f of x plus 2, I am going to substitute the x plus 2, and I'm going to use highlighters to show you. There it is. This x plus 2 is going here and here. So when all is said and done, now it has become x plus 2 times x plus 2 where the x's used to be. And that is what is supposed to happen. Then I would simplify. The simplifying here would be really easy. I would just multiply x by 2 and 2 times 2. So let's go ahead and see some examples of that, though, some more complex ones. Substituting an expression. Find g of 2x when g of x equals x to the second minus 2x plus 1. So essentially what they're doing is telling me here is to take this 2x, substitute it here, here, and here. Okay, so that doesn't seem too difficult. So I get g of 2x equals, and now I'm going to use parentheses. I absolutely must use parentheses. 2x squared minus 2 times 2x plus 1. So if you look at, and I'm going to again illustrate with my highlighter, if you look at, instead of x, now there's a 2x. Instead of x to the second, there's 2x raised to the second. Instead of 2 times x, it is 2 times 2x in here. So instead of all the x's, now I wrote 2x. So to simplify it, what I am going to do is I am going to leave the left side alone, because again, there's nothing to actually simplify there. So g of 2x over here equals, and then I'm actually going to perform the exponents first again. So exponents first. So 2 squared and x squared gives me 4x to the second. So what I did is I took this and I wrote its actual definition, which is 2x times 2x. Okay, that's what this means. So 2 times 2 is 4, and x times x is x squared. So that's where I get this from. And then I'm not doing any of the other steps yet, because now I'm going to do multiplication here. And I'm actually going to need to erase this and go back. And it'll come in a little more like this. There we go. Because now I'm going to use the space here to write g of 2x equals 4x to the second, and then I'm going to multiply. So 2 times, so minus, and then so 2 times 2x is 4x, and that's finished, plus 1. And then I need to combine any like terms here. Well, do I have any like terms? Nope. 4x to the second, negative 4x, and 1 are not like terms. So this is my fully evaluated function after substituting 2x. And so I'm going to show you what happens when you substitute a binomial expression. So binomial is 2 terms, x plus 3. We're going to learn more about binomials later on this year. But instead of x, okay, I'm going to put this, x plus 3, in everywhere. And it's going to go here, it's going to go here, and it's going to go in there. So when I write it out, I get f of x plus 3 equals 2. And then I need to do the x plus 3 here, squared, plus 4 times x plus 3. So you're going to need a little more room for this one, minus 3. So using my highlighter, I can show you that I have done the substitution by writing it in place of the x's in the original equation. And now I need to do exponents first. All right, so exponents. So I'm going to do the exponent step first, which is to take x plus 3 and take it to the second power. So f of x plus 3 is equal to 2. And then I need to actually exponentiate this. Having x plus 3 to the second power like that is telling you, so x plus 3 to the second power actually means x plus 3 times the quantity x plus 3. So we've practiced multiplying polynomials before, but essentially what you're going to have to do is this. You are going to have to, and I'm going to use different color pen. Yeah, I'm going to use different color pens here. You need to do 4 multiplications. You need to do this one times this one. You also have to multiply, so I'll go red next. You have to multiply x by the 3 in here. And then you also need to multiply 3 by x. And you need to multiply the 3 by 3. So every part of the equation has 2 different dots on it. So let's go ahead and do that. So if I do the purple pair, x times x, all right? If I do the purple pair, and I'm going to use a purple pen to color code it, I get x to the second power. If I do a red, then I do the red times the red, x times 3. So I'm going to use my red pen to do that. Gives me positive 3x. And then the next one was the yellow pair. So I'm going to multiply 3 times x again, which is also 3x. I apologize that it's hard to see, but it's there, I promise. And then the last one was the green times the green, which is 9. So we're going to go ahead and add those all together. So x squared is x to the second power. Red and yellow make orange if I remember correctly, but I'm just going to do it in red. 3x plus 3x is 6x. And then the green 9 stays the same. Okay, so there's the elementary crash course on that. So you're going to substitute this entire expression up here as x squared plus 6x plus 9. And then you have plus 4 times x plus 3 minus 3. So I still have a little bit to go here because now I have to do all of the multiplication. So f of x plus 3, and I'm going to leave a little room for the arrow to go through, is I'm going to take the 2. I'm going to take the 2 and I'm going to distribute the 2 to here, here, and here. And with the 4, okay, I'm going to take the 4 and I'm going to distribute it to here and here. So if I go ahead and multiply those all through, I'm going to get 2x to the second power plus 12x plus 18. So that's all the green ones, and I'm actually going to need to move the multiplying word over. That takes care of all of the green ones, so that's where they came from. And then 4 times x is positive 4x, and 4 times 3 is 12. So those are, and then the negative 3 drops down. Those come from the blue parts. So now I'm going to combine all my like terms, and we will be fully done with this. So f of x plus 3 equals, there's only one 2x to the second power. There's only one x to the second power anywhere. So it's 2x squared. I have 12x plus 4x, which is plus 16x. And then I have 18 plus 12 is 30. Take away 3 is positive 27. So there is my completed evaluated function. And guys, I hope that the color coding really helped you here. I know that it can be tough to take in all of the different things that are going on here, so I really hope that the color coding actually helped you kind of keep track of what I was doing. The last type of thing that we need to see with function notation is working backwards. They say that in this problem, it is stated that f of x equals x to the second power minus 4. If f of x equals 8, what is the value of x? Notice, okay? I want everybody to notice this, that the problem states f of x equals 8. And that was, I'm going to rewrite that because I don't like how that was written. They say f of x equals 8. All right? They're not saying, okay, if I wanted to work forwards, they'd be saying f of 8 equals blank. They left the x blank. If you see this phrase here like this, this is the output. Okay? So f of x equals 8 is actually the output. And I'm going to wait for my my notebook software here to catch up to me. But in the meantime, what I am going to do is I am going to replace x in the function with 8. So my thing finally caught up with me. So this is going to be, this means output. Okay? If you see f of 8, that means input. But I have an output. So to fix that, excuse me, not to fix that, but to follow what it means that 8 equals x to the second minus 4. Remember, it was f of x equals x to the second minus 4. Well, in this case, this phrase, f of x equals 8, means that we're going to replace all of this with an 8. So I have to work backwards to try to find what x is going to be equal to. So following the reverse order of operations, if I add 4 to both sides, which is what I'm supposed to do, I get 12 equals x to the second power. And then I'm going to take the square root of that. And I get x is equal to the square root of 12. Plus or minus. And there really isn't any, like, if you actually look through it, it's a decimal, and I don't want decimals. So we're not putting any decimals on here. This is the exact answer that I want. So that's it for the video, guys. Now we know what a function is. It's an equation where each input has exactly one output. We can identify a function based on its graph using the vertical line test. Function notation is used to tell an equation is a function, and then we can substitute inputs in to get specific outputs. It's possible to substitute entire expressions into functions to get entirely new functions when simplified. And then saying f of x equals 8 is different than saying f of 8 equals. Remember that f of x equals 8 is an output, where f of 8 equals blank is an input when solving. So that's it for the video, guys. Thanks for watching, and I'll see you in the next one.